Okay, so let's talk about factoring the sum and difference of perfect cubes. Now, before we could talk about, how to do this, let's just talk about what perfect cubes are. All right, so I'm going to make a little list of them here. So if we said, what is 1 cubed? 1 times 1 times 1, it would just be equal to 1. So 1 cubed is 1. All right, if I said, what's 2 cubed? 2 to the third power. 2 times 2 times 2 is 8. 3 cubed, 3 to the third power. 3 times 3 times 3 is 27. And then 4 cubed in this list just keeps going. 5 cubed, okay, I'm just going to put a comma and dot, dot, dot. Now, we can also talk about variables that are perfect cubes. So our first variable perfect cube would be x cubed, because x times x times x is x cubed. So the cube root of x cubed would be x. So let's take a look at the next one. If we decided to take x squared and cube it, well, what that means is we have 3 x squareds being multiplied together. Now, if you recall, when you're multiplying terms with the same base, what we do is we add these exponents. So 2 plus 2 plus 2 is 6. So x to the 6th would be our next perfect cube. Okay, so now I'm going to do a little change here. Let's see. We decided to take x to the 3rd and cube it. Well, then we would have 3 x cubed. So this will now be x cubed times x cubed times x cubed. Again, when we're multiplying terms with the same base, we just add these exponents. So 3 plus 3 plus 3 is 9. Or even a shortcut way would be when you have a power raised to another power, you just multiply these. So 3 times 3 is 9. All right, so if we think about that, if we wanted to we'll do this off to the side, x to the 4th cubed. So we have a power raised to another power, so that'll be x to the 12th. Okay, we can do the shortcut. We could just multiply them. So if you notice what's happening with this list is really these are just increasing by 3 each time. They're multiples of 3. So if I were to take 12 and add on another 3, I would have x to the 15th, and then x to the 18th, and so on. So as long as an exponent is divisible by 3, a multiple of 3, it's considered a perfect cube. All right, so if you take a look in your packet, you'll see that in the section where it's factoring the sum and difference of perfect cubes, you'll see these formulas on the top of the sheet here. Now this would be the sum of 2 perfect cubes, because remember, a to the 3rd and b to the 3rd, because they have an exponent that's a multiple of 3, these are both perfect cubes, and this is the formula we're going to follow. If we have a difference, a subtraction sign of perfect cubes, you could pretty much see it's the same exact formula. The only difference is here the signs are different, and here the signs are different. Okay, so this may look a little confusing, so I'm just going to jump right into how these formulas work. All right, so if you look at number 1, what you'll notice is we have a sum of 2 perfect cubes, right? X cubed is a perfect cube, and 27 is a perfect cube. So the first thing I want you to do is I want you to take these terms and rewrite them as something being cubed plus something else being cubed. Okay, you want to say to yourself, what am I cubing to give me x cubed? Well, I'm cubing an x. What am I cubing to give me a 27? 3, right? 3 cubed. 3 times 3 times 3 is 27. Now, what we're going to do is we're going to follow along with the formula in order to write this out in factored form. So, if we look at the formula, it says when we have something cubed plus something cubed, that's equal to a plus b. What's being cubed in the first spot plus what's being cubed in the second spot. So here, if you look at what's being cubed, we have an x. And if we look at what's being cubed here, we have a 3. So we're going to rewrite this instead of a plus b, we have an x and we have a 3. So we're going to rewrite that as x plus 3. Okay, then if we follow along with the formula, we'll see it now says the first thing, let's take it and square it. So here, our first term that we have is x. So we want to take that term and we want to square it. Okay, notice this, even though this says a cubed, we're only taking this a, we're only taking this base and squaring it. So here we're only taking this base and squaring it. So I'm going to write that as x squared. Okay, then we have a subtraction sign, so let's bring down the subtraction sign. Now it says A times B. Again, we're only looking at the bases here, okay? So we're going to do this first base times that second base. So here our base is x, and here our base is 3. So we're going to do, I'm going to write it out like this for right now, x times 3. Okay, then we have plus, so we'll bring down our plus sign, and it says take your second base, right, take the b, and square it. So if we take our second base, which is a 3, and square it, we could write that as 3 squared. Okay, I'm just going to go through and make this look a little prettier. So the x plus 3 I'll bring down. There's nothing I can do with that. The x squared I can't do anything with, so I'm going to bring that down. Bring down the subtraction sign. X times 3, we usually write that as 3x. And then plus 3 squared is 9. So this right here would be our final answer. This is in factored form. If you took these two parentheses and distributed the x into the second parenthesis and distributed the 3 into the second parenthesis and combined all your like terms, you would actually be left with this original problem right here of x cubed minus 27. So this is our factored form. All right, now let's skip to number 4, the bottom of the page here. So if you look at number 4, we again have sum. Okay, we have an addition sign. So we're looking at the sum of two perfect cubes. These are both perfect cubes. So the first thing we want to do is we want to decide what is it that we're actually cubing to give us 27x cubed. Well, 3 cubed gives us 27, and x cubed is x cubed. So we're taking a 3x and cubing it in order to give us 27x cubed. Okay, then bring down the plus sign. And what are we cubing to give us 1? Well, 1. 1 cubed is 1. Okay, so now if we follow along with the formula again, it says here we have a base of an A and we have a base of a B. Okay, what they want us to do is they want us to take that first base and that second base and add them together. So here, our first base is 3x and our second base is 1. So we're going to take that 3x and the 1 and add them together. Okay, then in our next parenthesis it says take that first base and now we want to square it. So we're going to take that first base of 3x and we're going to square it. And I'm going to put that 3x in a parenthesis so I remember to square the whole thing. So I'm going to square the 3 as well as the x. All right, now I'm going to bring down the subtraction sign. And now it says take the first base of A and the second base of B and multiply them together. So here, instead of an A and a B, we have our first base being a 3x and our second base being a 1. So we're going to take those and multiply them together. So 3x times 1. And then we have plus the second base squared. So plus our second base is a 1. So we're just going to take 1 and square it. Okay, so again, let's just go through and just make this look a little nicer. So we could bring down the 3x plus 1. Now, when you square a 3x, remember we said before you want to square the 3 as well as squaring the x. So 3 squared is 9, and x squared is x squared. So that gives us 9x squared. And then minus 3x times 1 is 3x, and then 1 squared is 1. So this is going to be our final answer in factored form. Okay, so if you turn to the next page in your packet, this is the last question we're going to do together, number 5. This one is now a difference of perfect squares. You're going to see it's really pretty much the same exact thing, just the signs within our formula are a little different. All right, so you want to first say to yourself, what is it that I'm cubing to give me a to the 6th? Well, you're going to be cubing an a squared, because if you remember, we said earlier, a power raised to another power, right? We multiply these. So since 2 times 3 is 6, we're squaring, a squared is what we're cubing to give us a to the 6th. Okay, then I'm bring down my minus sign. Now, what is it that I'm cubing to give me 125 b cubed? Well, 5 cubed is 125, and b raised to the 3rd power is b cubed. So there we go. All right, now let's follow our formula. This time, it says a minus b. Okay, take that first term and subtract the second term from it. So we're going to take our, this time we have an exponent on it, but that happens. We're going to take our a squared, and we're going to subtract from that our 5b. So we could write that as a squared minus 5b. Okay, then we're going to open up another parenthesis, and it says take that first term and square it. So our first term is an a squared. So we want to take that a squared, and we want to square it. All right, then we have plus the first term times the second term. So plus, our first term is a squared, and our second term is 5b. All right, and then we have plus, take the second term and square it. So plus, we're going to take the second term here and square it. So we're going to take the 5b, put it in a parenthesis, and put a square on the outside, so we remember to square the whole thing. Okay, so then we're going to bring down the a squared minus 5b. If we want to take a squared and square it, remember, a power raised to another power, you just multiply, so that'll be a to the fourth. And bring down the addition sign. A squared times 5b is going to be 5a squared b. Okay, you put the coefficient first, the number first, and then just put everything else alphabetically. Okay, bring down the addition sign, and 5b squared would be, well, 5 squared is 25, and b squared is b squared, so 25b squared. And that is in factored form for us.